All right, so for part A, they're asking us to just find the area of R. So that should be pretty straightforward. We just got to make sure that we know the formula for the area in a polar curve, which should be 1/2 of our integral from A to B, from alpha to beta. And so if we're looking at the area of R, then we should be plugging in 1 plus sine theta cosine 2 theta to that, because that's the smaller function there. And when we do polar area, we got to square that. And then we got to determine what our limits of integration are. So we're going from this point where theta is 0, looks like, right? Theta equals 0, around to the point where theta equals pi over 2. So 0 to pi over 2, and your calculator will give you a value for that. What'd you guys get? Should have been 0.648. Yep. Good. And that was actually worth 3 points there. 1 point for the limits, 0 and pi over 2, and the constant of 1/2 out front. 1 point for the stuff inside the integral, and then 1 point for the final answer. Good or no? Wonderful. All right, part B tells us we've got a ray, theta equals k, between 0 and pi over 2 for k, that takes S and divides it into 2 regions that have equal area. We want to write an equation, we don't have to solve it, that has one or more integrals to give the solution for the value of k. Well, if we're dividing region S into 2 regions of equal area, with some line that goes through here, I don't know, maybe right around there. The integral that we need to do is just going to go from 0 to k, and then we'll do another one from k to pi over 2. And then what is the R value that we want to use for this region that's between the 2 of them? We need to take the outer function and subtract the inner function. So we're going to do region S comes from G minus F. So we do 0 to K, 1/2 out in front, of G minus F squared d theta, and you'd write G of theta minus F of theta squared. And then we'd set that equal to the integral from K to pi over 2 with a 1/2 out in front of G minus F squared d theta. And if you got rid of the 1/2s, that's fine. Also, you don't need the 1/2s there, of course. They cancel each other out. Everybody good with part B? One point for having 0 to k, k to pi over 2. So 1 point for the right limits, and then 1 point for the right things inside the integral. Any questions or issues with that one? All right, part C is we've got a new function, w of theta, which is the distance between f of theta, theta, and g of theta, theta. We want to write an expression for w of theta, and then we're going to find the average value of that distance of w of theta. So if w of theta is just the distance between f and g, then w of theta ought to just be g of theta, the outer function, minus f of theta, the inner function. And that's all w of theta should be, outer minus inner. And if we're looking for the average value, we'll just use the mean value theorem for integrals. 1 over 5 or 2 minus 0. And then have the integral from 0 to 5 or 2 of w of theta d theta. And we're not doing area here, so we don't need a 1/2. We don't need a squared or anything like that. Oh, wait, no, that's not what we're doing. Yeah, no, we are finding the average value. Yeah, okay. And what did that come out to be if you looked for the average value of that there? Should have been, what did you guys get? Hopefully 0.485, I believe. Yep. And that was worth 2 points, 1 for w of theta, 1 for the answer. And you needed to have this setup using the mean value theorem of integrals. So you can just show the setup as well. All right. So let's see. Part D says, using our information from part C, find the value of theta for which w of theta does equal that average value. And then we want to know, is the function w of theta increasing or decreasing at that value? So first off, we just need to set w of theta equal to 0.485, equal to that average value. And w of theta was just like we said, g minus f. So you'll just graph g minus f, graph 0.485 and see where they intersect. And it looks like that came out to be theta equals 0.581. And then they want to know if w is increasing or decreasing there. So you just look for w prime of 0.581. And w prime of 0.581 came out to be negative 0.582. So we would say it's decreasing because the derivative is negative. And that was worth 2 points also. 1 was for getting that value and 1 was for decreasing with a reason. How do we feel about that? Any issues there? Yeah, so Noah, saying that they get closer to each other over the entire interval, while that is true, that is not, that's not an explanation that they're going to give you points for. They want a legitimate calculus reason why it's decreasing. Even though, yes, clearly it's obvious that that distance is decreasing. So make sure you do the derivative and show that. Everybody good? Any other questions on that one? All right, and then I asked you guys to do this one, yeah? How'd this one go? This one go okay or no? Any of you like still there listening to me or no?
Yeah, it was okay.
It was okay.
Yeah.
I guess that's good. Could be worse. All right, let's go through it. So, part A, we got the shaded region that's inside r equals 3. And also inside 3 minus 2 sine 2 theta, we want to find the area of that region R. So in order to find the area of region R, what did you guys do? Perfect. Yeah, that's what I would do. So just take this quarter of a circle. Right? What's that quarter of a circle? That's 1/4 pi times the radius squared. So it's like that's got a radius of 3 based on the fact that it's a circle R equals 3. So 1/4 pi times 3 squared. And then we will add to that the integral from 1/2 of the integral from 0 to pi over 2 of 3 minus 2 sine 2 theta squared d theta. So we get 9 pi over 4 plus whatever this integral comes out to be, the one from 0 to pi over 2. And what did that come out to be? 9.708. Sound good to everybody? And 3 points for that, 1 for the integral, 1 for the right limits, and 1 for the final answer. All right, part B. So for 3 minus 2 sine 2 theta, we want to find dx d theta. So we know that x is r times what? X is r cosine theta, right? And so if we want dx d theta, we just take the derivative of that at pi over 6. You got a calculator for this one, so your calculator will tell you what that value is. You don't actually have to take the derivative by hand. And it should have come out to be 2.366. Oh, sorry, negative 2.366. Everybody good with part B? That was pretty easy, I hope. 1 point for the expression, 1 point for the answer. All right. Part C, we got a distance between the two curves is changing between 0 and pi over 2, obviously. We want to find the rate at which the distance between them is changing with respect to theta when theta equals pi over 3. So the distance between the two curves ought to just be the outer one minus the inner one. Right, so we'll say d is equal to 3 minus, and then what was it? 3 minus 2 sine 2 theta, right? So that's d. And we want to know the rate of change of that when theta equals, what was it, pi over 3. If we wanted to simplify this down, we could just say that d is 2 sine 2 theta. And d prime of pi over 3 gives you negative 2. Good or no? Wonderful. And then part D, we got a particle moving along the curve r equals 3 minus 2 sine 2 theta. And we're given d theta dt is 3. We want to find dr dt when theta is pi over 6. So we should, with any luck, recognize that this is, I mean, first of all, it's a related rate, but it's something that we're going to use the chain rule for, right? Because we should be able to say that, get the page here, that dr dt, the derivative of r with respect to t, should be the derivative of r with respect to theta, which is the variable that we have r in terms of, times the derivative of theta with respect to t. Right, so dr dt should be dr d theta times d theta dt. And we're looking for dr dt. And we don't have dr, well, you do have dr d theta. No, we don't have dr d theta, but we can get dr d theta really easily. What's dr d theta? Should be, what should that be? Looks like it should be -4 cosine 2 theta. And then d theta dt was 3. And so then we'll just evaluate this at the theta value that they asked us for. What was the theta value they asked us for? Pi over 6. Just plug in pi over 6, and looks like that comes out to be -2 times 3, which is -6. And you got 1 point for setting it up properly and 1 point for the answer. Good or no?
Good.
We're feeling a little better about the area volume, especially with the polar ones now. I know it's been a while since we've done some, so. Has this been helpful, doing these ones? Yeah, hopefully.
Yep.
Oh, good. All right. And let's see, I also asked you guys to work through this one, right? So let's take a look. So for part A, we're looking for the area of S, which is a shaded region inside the circle r equals 3, but also inside 4 minus 2 sine theta. So if we're looking for that area, how are we going to set that one up? Here's what I would do. I'd break it down at these intersection points. Yep, so first we'll figure out where they intersect. So we got 3 equals 4 minus 2 sine theta, and you'd want to show this. And you determine that the theta values that they intersect at are what? Now this becomes sine theta equals 1/2, so that'll be pi over 6 and 5 pi over 6. And so we know that from 5 pi over 6 around back to, this would become 13 pi over 6. It's just the circle, it's just that portion of the circle. Everyone agree with that? What I've shaded here in red is just a portion of the circle. And all we need to worry about then for the rest of it is the integral from pi over 6, we just said that, to 5 pi over 6 of 4 minus 2 sine theta squared. So that's the blue part. Everybody good with the blue part?
Yeah.
And then the red part, well, how much of the circle is that? If we cut out from pi over 6 to 5 pi over 6, that's 4 pi over 6 that we've cut out. So we've cut out 2 pi over 3, which how much of the circle is 2 pi over 3? That's a third of it, right? So we've got 2/3 of a circle. So 2/3 pi times the radius, and in this case, that radius is again 3 squared. So we got, looks like that's 6 pi plus whatever that integral comes out to be. You've got a calculator for this one. So you end up with 24.709. And 3 points for that. So 1 point was for having the right thing in the integral, 1 point was the limits and the constant of 1/2, and 1 point was the final answer. Everybody good there with part A? All right. For part B, we got a particle moving along the 4 minus 2 sine theta curve, so that at time t, theta is t squared. We want to find the time interval between 1 and 2 when the x coordinate of the particle's position is -1. So first off, how do we find the x coordinate of the particle if it's going along this curve? Well, the x coordinate should be r cosine theta. Everybody agree with that? And we are not looking for a theta value though. We are looking for a t value. So we know that theta is equal to t squared. So we will rewrite this as x in terms of t equals 4 minus 2 sine t squared cosine t squared. Everybody good with that? And we'll set it equal to -1. We will use our graphing calculator to graph this equation. We will graph y equals -1 and look for where they intersect, or we'll graph this +1 and look for its x-intercept. And it looks like that came out to be when t was 1.428. Everybody good with that? Any questions or issues there? All right. And that was worth 3 points. 1 point was for having an expression either for x of theta or an expression for x of t. The second point was for setting one of those expressions equal to -1. And then the third point was for correctly solving it. Everybody good there?
Yeah.
Okay. So for part C, what's it asking? For the particle described in part B, find the position vector. Okay. So, and then find the velocity vector at 1.5. So to find the position vector, we're going to need both the x coordinate and the y coordinate. We've already got the x coordinate, right? It's this in terms of t, so with the t squareds in there. But we're going to need the y coordinate. So y of, we'll say y of theta ought to be 4 minus 2 sine theta times sine theta. And so that would make y of t equal to 4 minus 2 sine t squared times sine t squared. And so now we've got the x of t and we've got our y of t. So our position vector ought to be 4 minus 2 sine t squared cosine t squared, comma 4 minus 2 sine t squared sine of t squared. Everybody good with the position vector? And our velocity vector at 1.5 ought to just be x prime at 1.5 and y prime at 1.5. And your calculator will tell you what both those values are. It'll take the derivative of this and the derivative of this for you, evaluate them at 1.5, make sure you're in radians, of course, and you end up with -8.072, -1.673. And that part was also worth 3 points. 2 points for having the correct position vector and 1 point for the velocity vector. Any questions on that one? Everyone's good? All right. Does anybody have any just random questions about any other problems that you've been working on, any of the full-length practice tests that are up in the Google Drive, any other problems from anywhere at all? Open to any questions you might have on any of these problems. All the difficult integral questions. What difficult integral questions? Yeah, I mean, they're not going to give you anything too crazy difficult in terms of integrals. You will normally see in some of the multiple choice, you'll have to do a little bit of partial fractions. You might have to do a little bit of inverse trig. You might have to do a little bit of integration by parts in the multiple choice. Usually there'll be a couple of integrals within the free response that require a little bit of these things, a little bit of partial fraction, maybe a little bit of integration by parts in the FRQs too, but most of it's not too crazy. They won't give you as many difficult integrals as I have given you throughout the year. Okay, let's see here. The weird trig ones. What do you mean the weird trig ones? Lots of functions being multiplied. Chances are there won't be a bunch of that. I mean, you might end up with one question like that in the multiple choice, but chances of that happening are not super likely. Okay, 1 second here. Let's see. Ryan, you were asking about, let's see, differential equations, FRQ, slide 9, part B. Let me make sure I'm pulling that up right now. Let me make sure I got the right thing here. Okay. Wait. Is that this one? Okay. All right, so part B here asks us to find values of the constants m, b, and r so that y equals mx plus b plus e to the rx is a solution to this. So the first thing that I would do here, if I were working through this one, is I would say that I've got a y in my differential equation. I know that y has to equal mx plus b plus e to the rx. So I'd write this, let me get a different color here actually. It's hard for me to see the green. I'd rewrite dy dx as 3x plus 2 times mx plus b plus e to the rx plus 1. And then, let's see here. From there, I think what I would do is I would just note that I get sort of two different things going on here. One is that if I let R equal 0, that's going to make this whole expression a lot simpler. So let's say if R equals 0, if R is 0, then we just end up with our differential equation here. What does it become? It becomes dy dx equals 3x plus 2mx plus 2b, and then that becomes plus 2, and then plus another 1. That ends up becoming plus 3. So let's see here. And yeah, so if R is 0, that gives us that this equation is y equals mx plus b plus 1, which would tell us that the slope of this is just m. And so the slope, which is just m, should be, this is a fun one. I don't think I've looked at this one. Let's see. That slope should be equal to 3x plus 2y plus 1 still. And that would then tell us let's see, what do I want to do here with this? Let's actually go back here. Let's say, no, I don't want to do that. M is 3x plus 2y plus 1. I still got my y's in there, though. Oh, yeah, here's what I would do. I'd say my derivative here, which we know, is m plus r e to the rx. And so if r, like we said, was 0, then my derivative is also just equal to m. And so we could then say that 3x plus 2y, no, I already have that, darn. 3x plus 2y plus 1 is still equal to 0. Good question. If I were taking the AP test, I'd skip this one and do C and D right away and then come back to it later. I guess I'd do this. I'd probably go with something like m plus r e to the rx is equal to this. What do we have? We had 3x plus 2mx plus 2b plus 3. Yeah, I guess this is what I would do. So I would set this one equal to this one that I just wrote out. Yeah, this will work out better. So if I do that, and then we go in and say that r is equal to 0, that gives us m is equal to 3x plus 2mx plus 2b plus 3. And then we'll subtract the m over to this side to get that 3x plus 2mx plus 2b plus 3 minus m is equal to 0. And then we can say that on the left-hand side, I've got 3 plus 2m x's. And on the right-hand side, I've got 0 x's. And so that should give us a value of m is equal to negative 3/2. So there's a start. And then if m is negative 3/2, then we should be able to go back in here to this one. If m is, so let's say r is 0, m is negative 3/2, and then we had 2b plus 3 minus m equals 0. So minus m ought to be plus 3/2. And so we'll end up with, what does that come out to be? 9/2. So negative 9/4 it looks like for B. Everybody good there? Does that make sense, Ryan? Correct, yeah. 3 plus 2m is the number of x's on the left, and 0 is the number of x's on the right. Correct. And then you'd really want to go through and do this for when r does not equal 0 as well. So we want to go and say if r does not equal 0, what did I have over here? I had m plus r e to the rx equals 3x plus 2mx plus 2b plus 3. And so if r is, if we don't let r equal 0, then let's see here. What are you saying, Noah? No, because you got the 3 from letting r equal 0. Oh, I got the 3 from letting r equal 0. Yeah, what was my equation? What did I have there originally? Yeah. Okay. So we had 3x plus 2, what was it? 2mx, I think, plus 2b. If you distribute the 2 through, plus 2e to the rx plus 1, I believe. Is that right? Does that look right to everybody? Okay. Then 2e to the rx's. So we'd look here and we'd say, well, in this case, if r isn't 0, I've got an r e to the rx on this side, and I've got a 2e to the rx on this side, so r would be 2. So we can then, once we decide that r is 2, we can then go in here and we're just left with our m on this side. We'll bring the m over, so we'd have effectively the r e to the rx and the 2e to the rx can go away now, and we're just left with 3x plus 2mx plus 2b plus 1 minus m is 0. And then we on this side have 3 plus 2mx's. And then on this side we have 0 x's, and that would give us m is equal to negative 3/2, which I believe is what we got before. And then we still end up here with 2b plus 1 minus the negative 3/2 equals 0, because the constant on the right is 0. And then this time that should give us a value for b of negative 5/4. So it looks like. Yeah, that's not atrocious once we got it set up right. It's just I think we did one also before similar to this recently, where we're looking for constants of like m and b, which was a lot easier. Yes, that is two different answers, Noah. And hopefully that made sense, Ryan. I don't know, did anybody happen to know what year this one was, so I can look up the scoring guidelines on it? Otherwise, I can search for it. Do you know, Ryan, since you were working through it? Okay, give me 1 second. What values were? Let's see, in 2007, maybe it was, oh yeah, I was just gonna say maybe it was Form B. Okay, there it is. Let's see here. Yeah, that part was worth 3 points. So it was the most points of that particular problem. They would have given you 1 point for finding this m plus r e to the rx. And then it says 1 point for a value for r, and then 1 point for values for m and b. Yeah, and they show both. They show when r is 0. They show when r is not 0. I don't know. It's hard to say. I mean, I don't think you would have needed to get both. I don't think you would have needed both. It does, like, they got a big or in between here. So it's hard to say if they would have required both of those to be solutions. Let's see here. Oh, the thing I pulled up has like student work. Let's see. Yeah, it looks like they gave full points to somebody that only found one set of the 3 solutions. So you could have got either 0, -3 halves, and -9 fourths, or you could have got 2, -3 halves, and -5 fourths, and either one would have been good.